if one of you tells me that they're hinky. Here's what I mean by that. One of the answers, which was it, Brittany? Do you remember it all? Right here. 2x plus 6 over 5. The instructions clearly say put it in simplest form, yes? Well, in my world, simplest form means factored, right? Because if I gave you 3/9, those are pretty simple forms, yeah? But that's not simplified, is it? What is that really? 1/3. So in my world, this should be 2x plus 3 over 5. Everybody understand? And we've encountered this year before when we were doing our radicals, right? Sometimes the answers would leave a radical that could be simplified. I don't like that. So for all, simplify. Okay? Now, if you do simplify to something like this, and then you check the answers and you see that, you really should be able to see that they're the same thing, yeah? Like it only takes a second to recognize, 2x plus, 2x. All right? So you have to get out of that thing that you kids do where you flip to the answers and it's not what you have and you automatically assume that you've done it wrong. Please don't do that. Okay? You're all very good at math or you wouldn't be here. I know sometimes some of you, and no names will be mentioned, but some of you feel that you're kind of a little bit weak at math. And that's crazy talk. Because you're in the second most difficult math course you could ever possibly take, and 99% of you are passing it with a decent grade. Okay? Okay. Everybody understand what I'm saying there? Chances are you did it right. Right? You've been flipping to the answers in the back of the book for 12 years of your life. How many times have you found those answers to be wrong? On a fairly regular basis, yes? Do we make mistakes? Everyone does. Do mistakes get through? Yes, they do. Because everybody involved with proofreading and printing and everything, every one of them can make a mistake. Right? You guys have all gone on the internet and found those stupid signs that are posted weirdly and stuff like that. Right? That Del Taco free shavakadu. Everybody, see, McKenna's already laughing about it. That was all over the place. Like that was the height of humor because the S slid over a little bit. So instead of fresh avocado, it was free shavakadu. But it was F-R-E. It wasn't F-R-E-E. It wasn't fresh avocado. It was fresh avocado. And everybody was like, free shavakadu because of that idiot who had his cell phone by the sign. Now, what would be really funny is that idiot, I'd like to get my hands on some of that idiot's work from his life and put it all over the internet and find out how well it stands up. But, that's not how the internet works, right? The internet is only there to make sure everybody else in the world looks like a moron, not you. I'm sorry, I shouldn't bug that guy. My family's been saying let's get some free shavakadu since that came out. And we eat a lot of avocado. Guacamole is a big thing in our house. If it's not in your house and you don't like guacamole, shame. You should learn to. It's delicious. Does anybody not like guacamole? Be honest. Really, you don't? Not even a little bit? Huh. Interesting. Only one of you? You don't like avocado or guacamole either? Like guacamole you buy and get it in the store, or like guacamole you make at home?
I've never tried guacamole, but I'm just assuming I'm not.
Fair enough. There are some assumptions you can make. I'm not going to like prairie oysters. Like, I'm probably not going to try bull testicles because I'm okay with not liking them. But you should probably try guacamole, Lennon. You should. Now, St. John hates guacamole. He won't touch the stuff. He won't touch it. But my daughter loves it. She's taken over making it. I don't even have to make it anymore. And she's all, cookie about it. It's like, oh, a little bit of this and a pinch of this. Oh, it needs a little more lemon juice, a couple more drops. Oh, God, Beth, just make the guacamole. But that being said, she really does a good job with free shavakadu. It's delicious. Her guacamole is better than mine. All right, so we're all good with this. Nobody needs to talk. Oh, Madison hit me. 1H. Oh, yeah, 1H is weird. Yeah. So we factor it, yeah? Does that top one factor? Can we factor a sum of squares? Oh, right. So we don't have to worry about the top. Thank you. The bottom is x plus y, x minus y, yeah? Right? So I'm not allowed to have zeros there, agreed? So x plus y cannot equal 0, yeah? Which means y cannot equal negative x. And over here, y cannot equal positive x, right? So y can never be x, because if y and x are equal, then y minus x is going to be 0, right? Or x minus y. And how did they write the answer? Because they write it weirdly. Yeah, x can't be negative y or y. Okay, so they just wrote it the other way around, right? X can't be negative y, and x can't be y. I just have it written this way. It's the same thing. It just means you can't have the same number under there, right? Because if you had 4 minus 4, if you had the 0.44, 4 minus 4 would be 0, and this would be dead. And you couldn't have the 0.4 negative 4, or the other way around. Anything else? 2D. Yeah. So, if I were doing this, I would factor this out, and I would get negative 1 x plus 3 over x plus 3, right? Cancel, cancel. That's what's left. I'm sure that's what the answer is. Did it want restrictions? No, assume no denominators are zeros, so no, don't worry about restrictions. This trick is something that I have shown many, many times to you. It's not a trick, right? Because you can always divide out 1, yeah? So if you see a negative x, chances are you're going to want to bring out a negative 1. All right? Because math guys and math ladies and math everything else's do not like negative variables. Okay? Everybody else good? I'll wait. I'll do my usual going once, going twice, going thrice. And on the last phoneme of thrice, somebody will say another number. Going once. Oh, you messing with me. You hit me on the 1. Is that just so you can do it later? So you can hit me on the thrice? Okay. 5C. So r plus 3, r plus 4 over r plus 4, r minus 1, yeah? R plus 4, r plus 4. R plus 3, r minus 1. Whoop! Not minus 11, you idiot. And of course, if we were doing restrictions, would we check our restrictions where it's yellow, or would we check our restrictions where it's blue? Notice I'm still waiting. Yellow. If you check it where it's yellow, it covers the blue one, right? You have to check it where it's yellow, because that's originally, this is what it was, right? So when it's yellow, the answers are negative 4 and positive 1, yeah? So if I use positive 1, 1 plus 3 is 4, minus 4 is 0, right? That's not allowed. If I use negative 4 squared is 16. Negative 4 times 3 is negative 12. 16 minus 12 is 4. 4 minus 4 is 0. So both of them give me a 0 in the denominator, if we go back to the original. Does everybody understand that? Yeah? You got it. It can never be 0 in the denominator. At any point. Not even, or even, wait. It can never be 0 at any point in the denominator, even before you've simplified. Anything else? I'm trying to hypnotize you. Yes. Look deep into the Christmas ball. No, it's not very heavy. Yes, you have pierced ears. You want me to sanitize one for you and you could wear it? Okay. Okay. That was horribly presumptuous of me. Maybe you don't have pierced ears. Well, I know that, but it was regardless presumptuous of me. You have 6? That might weigh your ear down. Brittany would be walking in circles. All right, we're good to go forward. Moving on. Excellent. We are on the middle of page 168. Multiplying and dividing rational expressions. Oh, I need those tests back. I'll do it later. All right. Multiplying and dividing rational expressions. You are intelligent young people. Is that a rational expression? Yes, it is indeed. Okay. So, since you know that that's a rational expression, and you all know how to deal with fractions, then what word is going to go right there? Fractions. Multiplying and dividing rational expressions is exactly the same as, and I'm going to make it a little longer because I'm a math teacher, multiplying and dividing fractions. It's exactly the same thing. So I'm going to draw a line in the middle. I'm going to put multiply on this side. X over y times a over b. What is the answer? XA over YB. You just multiply them. Yeah? All right. And over here, I'm going to write it in brown. X over Y divided by A over B doesn't make any kind of sense. So we remember that it's really X over Y multiplied by B over A. And what is our answer? XB over YA. Now, something weird happens here. Where are there no zeros allowed to be on the blue side? In the denominator. So, y cannot equal what? 0. And b cannot equal what? 0. Yeah? What about the brown side? Y can't be 0. Can A be 0? No. Can B be 0? No, because you're never allowed a negative or a 0 denominator. Yeah? Yeah. Now, let's go to this question. If you are most kids who were educated in Canada, you were taught to add fractions first. And your teacher started you off, don't write this down, started you off with 1/2 plus 1/3. Right? And your teacher probably made you, if your teacher was thinking, your teacher probably gave you some blocks or some crap or circles and said 1/2 plus 1/3. And you were like, because you took this and you brought this circle over on top of here, and you saw that you got this. And your teacher was like, okay, how much is that? And you were like, I don't know, Mrs. Bad Crumble. And then Mrs. Bad Crumble showed you this, 1/2, and then this. And she said, isn't 1/2 3 6s? And you went, yes, Mrs. Bad Crumble. And isn't 1/3 2 6s? And you went, yes, Mrs. Bad Crumble. So how many sixths do we have there? 5 sixths. And then Mrs. Bad Crumble said, but we have 2 and 3. And you said, I know, it's blowing my mind. And then she taught you lowest common denominator, and you were like, right? That's about grade 3 and 4 in a nutshell for fractions. Yeah? For most of you? Right? And adding fractions and subtracting fractions still screws you up today in the 11th grade. Okay, grade 6. Regardless, we did it in grade 3 and 4. Anyways, you've all seen this, yes? And Mrs. Bad Crumble spent weeks on adding and subtracting fractions, didn't she? Forever. And then you got to multiply. And Mrs. Bad Crumble said, remember back when I taught you how to add fractions and you all thought the answer was 2/5? Because that's what you all thought. Some of you still write that now. That's what you thought it was. And Mrs. Bad Crumble said, why did you think that? And you said, well, because I did 1 + 1 and 2 + 3, Mrs. Bad Crumble. And she said, that's wrong. But she didn't, because it's elementary school in Canada. She said, that's a really good idea, but you could probably do it in a better way. Which is code for you're wrong. Anyways. So, when Mrs. Bad Crumble showed you this, and you all said 2/5, and then she spent 3 weeks showing you how to add fractions, she then went to multiply and said, now remember back when you screwed it up? Yes, Mrs. Bad Crumble. Well, when it's times, you get to do that. And she did, so it's 1/6. And then she walked away, right? She spent 6 weeks explaining why this works, and 1 day explaining this, because it's what you wanted to do, right? And in grade 3, that's about as tough as a multiplication question as you got, yeah? Maybe they went a little crazy and did something like 2/5 times 3, 2 times, no, that will be, 3/4. And you went to 6/20. And then she made you simplify that. Right? That's about the extent of elementary school multiplying of fractions, right? We've done some number theory since then, haven't we? How many numbers are there? Infinite amount of numbers. Are some of those numbers big? Do we sometimes take a big number and break it down into smaller numbers? Sometimes. So we'd better be good at dealing with fractions with numbers higher than 1s and 2s, yeah? Okay. So now we're back to the 11th grade. But you're still thinking in grade 3 terms. If you haven't been through my class, all of you are going to do this as 5 times 4 over 8 times 15 and get 20 over 80 over 120 and then get 1/6. Yes? That's the way I would bet 90% of you would do that. Of course, now that you've done some rational expressions and you're aware that these order doesn't matter because multiplying is commutative, yes? Isn't this the exact same as 5 over 15 times 4 over 8? And isn't that 1/3 times 1/2? And isn't that 1/6? Which means When you are here, 5 over 8 times 4 over 15, all you need to do is check upsy downsies. 5 and 15 work together. 5 goes into 15 once, goes into 15 thrice. 4 and 8 work together. 4 goes into 4 once, goes into 8 twice. 1 times 1, 1. 2 times 3, 6. And you've all seen that because that's what I showed you in the 10th grade. Because why would you waste your time with all this? Right? So now, take this knowledge and apply it here. How will we apply it here? Let's do that now. Let's pretend that you all have no idea how to approach this. But you're in the 11th grade, so you remember that you only need to go do one step, and that will probably lead you somewhere else. Do you see anything in this entire expression that you could make purtier or simpler? Pardon me? He waited patiently. The a squared plus minus 9, can you make that simpler? I bet you can, because you all know how to factor because you're in the 11th grade. A plus 3, a minus 3. Is there anything else you can see to factor? The other a squared. Okay. How are you going to factor that? That we factor it 1,000,000 times. I use it all the time because you can see it immediately. Is a plus 3, a minus 4. Yes? And then this is already factored, the other two sides. Now, what do you see just like here? Do you see anything on the top and bottom that work together? I see a minus 3 and a minus 3. Does order matter? No, so they're both gone. What else do you see? A plus 3, a plus 3. Gone. What else do you see? A minus 4, a minus 4. Gone. What's left? A minus 1 over 2. Just like what we did here, except you're doing it with with binomials. Yes? Why are we allowed to do it? What do these brackets mean for a minus 4? It holds it together. Is a minus 4 two separate things? Or is it one thing? It is one thing. If you know the value for a, if I told you a was 9, then what is this going to be? 5, just like we had right there. It's just a number. Does everybody understand? Now, the only thing that is new to you here is remembering to check for restrictions. What are they? A cannot equal plus or minus 3. Why? Because that would give me a 0 right there, yes? 3 squared is 9, 9 minus 9 is 0. Negative 3 squared is 9, 9 minus 9 is 0. What else can a not equal? 4, because 4 minus 4 would give me 0 right there. Can a equal 1 in this case? Yes, because am I allowed to have 0 in a numerator? Yes. What if this was divided by? Could a equal 1? No. Does everybody understand? Is there anything new here? No. Is there a lot of writing and work to be done? Yes, but we already know how to do that work. What am I going to do with my 4 colors here? What am I going to do with yellow? Y plus 3, y minus 3. There's the yellow. Over. What am I going to do with blue? R, Then what is that going to give me? R squared minus 1. Wait a minute. Don't I recognize something to do with R squared minus 1? What is that? R plus 1, R minus 1. There's my blue. And I should have shifted that out so it was more in the center. Yeah? Times. What's my green section? R minus 1. There's green. And do I need to do anything with purple? No. Now what do I get to do? Cancel everywhere. Where? Anytime the same term is in the numerator and the denominator. But remember, it's entire terms. Okay? That 3 does not cancel with that 3 because it's part of this entire binomial. So this is gone, this is gone, this is gone, this is gone. R is gone, R is gone. What is left? Y minus 3 over R plus 1. When should I have checked my restrictions? Where the highlighting is or where the highlighting is not? Where the highlighting is. R cannot equal 0 plus or minus 1, and Y cannot equal negative 3. Is everybody cool? Please notice we have done nothing at all new. But we are taking grade 6, because that's when Mrs. Bagcrumble did fractions. We are taking grade 10, because that's where Mr. Myers, for most of you, taught you to factor. Some of you learned it in grade 9 with Mr. Hirschman, maybe. And grade 11, where we put it all together. Aight? Number 3 kills kids. What about number 3 kills you? Pi, because for some strange reason, you all know that x over x equals 1. But if I write pi over pi, I don't know. I don't understand why pi messes you up. 3 pi you treat exactly the same as what other mathematical expression that you use all the time? 3x. It's 3 times the next thing. We just write pi because if we were to write the number for pi, it would take us till when? Forever, because pi is not a number. Okay, I know Mr. and Mrs. Bagcrumble told you pi was 3.14, but it, of course, isn't. So, what are we going to do with 3? The same thing we have done every time, the same thing we have been doing since grade 4, 5, and 6 when we have to multiply fractions, right? Is there any factoring to be done? Any factoring to be done? No. Is 2 in the denominator? Is 2 in the numerator? Nice. Is pi in the denominator? Yum. Is pi in the numerator? Double yum. Now they're gone because we've had dessert. Is r in the numerator? Denominator. Yes. Is it in the numerator? Yes. What's left? dh over d minus 2. Now, no matter how many times I discuss this with you, and no matter how many times I show you why this isn't true, at least half of you are going to do that. You are. Even though I've shown you conservatively 100 to 150 times why you cannot do that. Why can't you do that? Because this is not d. This value is D minus 2. All right? If you don't believe me, and I've shown you this a million times, D equals 5. What then is my numerator? 5H. What is my denominator? 3. Can you cancel 5 and 3? No. Does everyone understand why you cannot do that? Can we please not do that? Okay. When I give you your next quiz, I'm going to ask for your estimates for how many people on the quiz will do that. I'll give you over-under on it. Now, I've made a big deal out of it because you think that I'm going to make a deal out of it on the quiz, and you think that I think you're really going to do it. But no, I'm making a big deal out of it now, so you all are like, I'm going to prove Myers wrong and do it right, that dick. I'll be like, oh, darn, you did your math correctly? You stupid punks, how dare you? Oh, wait a minute, I want you to do your math correctly. So really, I'm sticking it to the man. What are you doing with 4? What's weird about 4? It's division. So what happens to the second polynomial? It reciprocates. What happens to the division? It becomes multiplication. When do I check for restrictions? Well, now is kind of hard before you reciprocate, because neither of these is allowed to be 0. Right now, I can't tell which one is 0 unless I do what? Factor it, yes? Now, you people are intelligent young people. You should have noticed by now that almost all of these parabolas factor, don't they? Right? What if you're doing math in the real world with things like parabolas for profit and stuff like that? Are they necessarily going to factor? No. So you got to bring all the tools to the party, right? If I need the zeros here and it doesn't factor, then I got to run that through the quadratic formula. But I am not doing that to you in class. Everything in class is going to factor, okay? If it's going to factor. So, how do I factor yellow? Excellent. How do I factor green? X and x minus 4. Now, is it okay for me to write times and do this reciprocating now? Do you understand what I mean? Where will blue go now? Up. Blue will go up there, yes? Where will purple go? Down. Purple will go down there. Okay? Where do I have to check for restrictions? What 3 colors must I check for restrictions? Green, blue, and purple. How do I factor this one? We've done this a million times. It's another one you should be able to see fairly easily. X plus 5, x minus 4, yes? Top one, you've seen it a lot. X plus 3, x minus 2. What are my restrictions? Right now, you should be able to do it in your head. There's one that a great many of you are going to forget because it's the one you always forget. X can't be 0 because of the green one, right? You always forget this one. And I know I'm making a gross generalization, and it's not every one of you, and it's not every time, but it's enough that it worries me. X can't be 0. What else? 4. What else? Negative 5. What else? Negative 3. What else? 2. Do I care that those aren't in numerical order? Do I care? No. Will you have future teachers that might? Yes. So watch out for it. Because I cannot guarantee the persnicketiness of future math teachers. I know that my kid's math teacher would dock him credit for that. Even though I heartily disagree. So now what do we get to do now that we're all factored? Start canceling. Where? X minus 4 and X minus 4. Nice. Somebody else find another one. I feel like Zorro now. I'm just slashing away. What's going next? Zorro. Everyone. Zorro. Zed. Zorro. What else? Minus 2, minus 2. What else? What else? If there's nothing else, is it okay to say nothing? What else? Nothing. X plus 2, X plus 5, over X, X plus 3. Now listen. If you come across an answer key like the last answer key, this might be written as x squared plus 7x plus 10 over x squared plus 3x, yes? Which way do I want to see it? Black or red? Black. Factor, 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 factor. Oh, I forgot. Factor. When? Always. What are we doing with 5? What's the trick? What's the trick with 5? I changed the letter. Does that mess with anybody? Of course not. What do I got to remember because of that? I got to reciprocate. So start factoring. Go. Am I faster than you? Am I better than you? No. It just means I've practiced more. The reason I am rushing is because my mother's last name is Svetlana. I'm Russian. I'm not Russian. I might be Russian. I actually don't know. I could be. Maybe my dad's last name really is Petrov or something. I don't know. So, the reason that I am speeding along is because I really want to see 6 with you before 9:30. What is weird? There's multiplication and division. So remember, when in doubt, go with what you know. If that wasn't there, would you know what to do? What would you do? I'd factor and reciprocate and multiply, right? If that wasn't there, what would you do? Factor and multiply. But there's no denominator there, or is there? It's 1. So you would just do it, right? Okay, so since you know what to do, you know what to do. What do we do with the green and the pink? Factor. What do we do with the blue and the yellow? Factor and reciprocate. Do we do anything with the purple? Do we do anything with the purple? We just remember that it's got a denominator of 1, yeah? We remember that the purple is numerator. Now, why is this difficult? Because I've gone and put a leading coefficient, and everybody hates those, yeah? Of course they do. You have to choose how to factor that. The way I factor it, of course, is negative 30, and the factors have to add to 7, so it is 10 minus 3. So it is, since it's 10, and there's a 2 there, right? It's going to be m plus 5 and 2m minus 3 over, what's coming out down here? M minus, oh, it's the other way around, isn't it? Sorry. It was 10 and 3, so it's m plus 3 and m minus 5. 5m minus... I got to write it all out because I'm trying to cram it in. It's m plus 10 over m plus 3 over 2 and m minus 10 over 5. So it's 2m plus 3 and m minus 2 minus 5. 10 over 2. There we go. Got it. 2m 10 minus negative 10 plus. Got it. Over. What's happening with pink? 2m m minus 5 divided by becomes times. 6 goes up. What's happening with that? Plus 3. 2m minus 3. And here, what don't we like in the purple now? I've talked about it today already. What about that purple bothers us? A negative variable. So what should we take out? Negative 1, and then I get 2m minus 3, yes? Now, since it's all multiplied, just start canceling. Is there an m minus 5 somewhere? Gone. Is there a 2m plus 3 somewhere? Gone. Is there a 2m minus 3 somewhere? Gone. And I'm left with negative 6 over 2m. Now, that's tricky. What is it? Negative 3. Where's the m? In the denominator. Where did I need to check for restrictions? What color's up top? Yellow has no restriction because it's only 6. But if it was a polynomial, we'd have to check yellow. Where else? Blue and pink. So, since it's really hard to do up top, I go to the factored version of them right there. What can't m be? 0 and 5. And I go to the factored version of blue right there. What can't m be? Plus or minus what? Three halves, right? Everybody cool? Page 170 is your work. Remember, there's a crap ton of questions there, yes? Do you need to necessarily do them all? No, but I think I have forgotten to supply answers. Are there answers on the next page? What an idiot. There'll be answers tomorrow.